Welcome once again to the Kiwi Astronomers podcast. We're going to tell you about what's going on in the sky and some events that have been happening this week and will be happening next week. I'm Gareth Davies. I'm been described as an amateur astronomer from Auckland, and I've got with me John Drummond, who is the past president of the Royal Astronomical Society of New Zealand, and is a keen astronomer. He runs Gisborne Astro Tours, and he has had two of his pictures appearing on New Zealand stamps. And he also knows an awful lot about comets, which is just as well, because today's subject is going to be comets. So, John, how are things in Gisborne?
Yeah, nice and sunny. Thanks, Gareth.
All right.
Yeah, beautiful down here.
Yeah. I know you, it's COVID lockdown, so you haven't been out surfing like you do at least 3 or 4 times a week, but you've got there's a camera looking at the surf. Is there anybody out there, anybody breaking the rules?
I haven't seen anyone. I think I was talking to someone yesterday. They say that there's people walking on the beaches naturally, but thankfully no one's out in the surf. So that's good. Well done.
Yeah, I wonder if being out in the, I suppose if you're out in the surf and you clonk your head, then that's bad, because the ambulance people have to come out and see you. I know all that story. So that's good right to know. Good to know that you're sticking to the rules.
Yeah. So
today's plan, as I said, is to talk about comets, and I know that you are a comet expert, because I attended a talk of yours not so long ago at Auckland Astronomical Society, where you told us about your exploits. So you can share that with the podcast listeners and YouTube viewers today. And also we've got a couple of questions and a couple of topics that have just come into the news. In particular, Rocket Lab's listing on the NASDAQ. And also the fact that 15 years ago, Pluto was delisted, keeping the NASDAQ linkage, delisted as a comet, as a planet. So anyway, the floor is yours. Tell us all about comets.
Okay, well, for those who don't really know, a comet is a body that goes through the solar system, and it's basically it's made up of a pile of gases, frozen gases, rock, and a conglomeration of material. And when it comes in close to the sun, it starts getting a lot of radiation from the sun, and basically the gases start going from a frozen state to a gaseous state. So it bypasses the liquid state in a process called sublimation. And as it does so, the gases start expanding around the comet's head or nucleus and forms a cloud around it, known as a coma. And then as the comet keeps on coming in towards the sun, the solar radiation from the sun, the solar wind, basically blows the material away from the comet and often gives a comet a tail. Not all comets are nice, bright, naked eye comets. We might see one every, 5 years or so, 10 years perhaps. Most comets are just little fuzzballs that come and go, unnoticed by the public. But when we do get a good one, they're certainly pretty amazing.
Let me get this right. It goes from ice straight to gas, missing out the liquid state. Is that right?
That's right. In science, they call it sublimation. Sublimation. Yeah.
All right. How does that happen? How is that? I didn't study chemistry particularly closely. How does that happen?
It's just the nature of the beast. I guess the environment where it is, the vacuum, and so on. It's not the conditions that you might find on Earth, where you've got ice and then it turns to water at a certain melting point, and then into a gas, and basically later on as the temperature increases. So it just basically mostly goes from that frozen state to to the gas, which makes the envelope around the head of the comet, and then as it gets blown away, that forms the tail. And an interesting thing is, as the comet comes in around the sun, it follows a big, long elliptical orbit, like Halleys Comet that last came in 1985-86. Takes 75 years, basically, say it's at the point closest to the sun. It travels out, goes out beyond Neptune, and then the sun's gravity manages to pull it back in to the sun, and to do a loop around the sun takes about 75 years. So as it does so, it leaves particles behind in its path, and the Earth goes through that path every year, and we get meteor showers, so shooting stars at certain times, and those are the remnants of comets.
So those meteor showers that we see, that we hear about, it seems to me that there are a lot more in the northern hemisphere than there are in the southern hemisphere. One of the few advantages of being in the northern hemisphere. Is there a particular reason why there are so many in the north and so few, it seems, in the south?
Oh, I wouldn't say so many more in the north. The thing is, they do have the Perseid meteor shower in August, which is a major one, and then they've had the Leonid meteor shower too, which gets replenished by Comet Temple Tuttle every 33 years. And when that comet comes around and replenishes the path of meteoroids, and the Earth goes through it every 33 years, then we can get storms. So yeah, the Northern Hemisphere has had storms, but and some good meteor showers. Southern Hemisphere also has them, but there's not as many people down here observing them. So I guess we hear more about the northern ones, perhaps.
What's the best one to see down south?
My personal favourite is the Southern Delta Aquarid meteor shower. You can see up to a couple of shooting stars per minute. Right. When it's a good year. Another very good one is around Labour weekend each year from here in New Zealand, when we pass through the path left by Halleys Comet, and we have the Orionid meteor shower. So those who know Orion,
not to forget the Eta Aquarids as well.
That's right. There's two meteor showers associated with Halleys Comet, and both produce nice meteors. Yeah. And the thing about those meteors is, as they come in, they're often fairly bright, sometimes brighter than the brightest star in the sky, but usually about the brightness of an average star. Wow. But they often leave a nice trail behind them that lasts for a couple of seconds, called a train.
Oh, really? Oh. What? So the meteoroid has a train, is that right?
Yeah. So it's a particular characteristic of Halleys Comet. The particles that are left behind have a certain consistency or size that actually has enough mass to actually leave that trail behind it. So you'll see a shooting star going through the sky, lasts 2 seconds, maybe 1, 2, 3 seconds, and then the trail where the meteor was will be sitting there for 3, 4, 5 seconds.
Really?
In fact, the most amazing one I saw was back in 1980, in the early 80s, when I saw a meteor, and it wasn't a bright meteor, but the thing about this one is it left a trail in the sky that lasted 27 minutes.
Wow.
Yeah.
Really?
Yeah, and it was quite amazing. Initially, it was just a straight line, but then with the winds and the upper atmosphere and all that it got distorted and so on. Kind of like contrails in the air get distorted.
Did you?
Yeah, 27 minutes.
You just happened to be observing?
Yeah, I was outside with my telescope just looking up and saw this meteor, and the train just kept on going and going and going. And I just wish I had gone and got my film camera and photographed it, but I kept on thinking, if I go and get my camera, it'll probably disappear. But no, 27 minutes later,
still out there. So comets are predominantly made of they're like cosmic snowballs, I guess, giant big ice.
Yeah, there was an astronomer, Fred Whipple, who basically called them dirty snowballs.
All right.
Because people thought they were just like a conglomeration of frozen materials, frozen gases, conglomeration of rock in there, and so on. And probes to them, to comets, have actually seen that they are quite a weak conglomeration of like gravel and dust and gases and so on. So yeah, they're pretty incredible things.
And how did they actually form? I mean, how come they're made of ice? How come they're not like all the, how did they come to be made of ice? It's very weird, isn't it?
Yeah, it's probably something to do with the formation of the early solar system 4.5 billion years ago, when the sun, there was a vast solar nebulae, and over time, it started to spin, and most of the material, in fact 99.8% of the material, formed the sun. And then when the sun reached the stage 15 million degrees Celsius, hydrogen atoms were getting smashed together with hydrogen atoms to make helium atoms. It ignited, so to speak, and then it blew off the material that was left around it. And a lot of those gases and ices and so on went out into the outer solar system, further away from the sun.
Is this
the
Oort cloud or Kuiper belt? Or
yes, that's right. Yeah, so the comets basically formed way away from the sun, and that hence the reason they have a lot of ice in them.
So what? So they're all forming, and most things are going around. What suddenly made them come wham in these orbits that go around the sun? How do they suddenly leap out of the Oort cloud or the Kuiper belt and suddenly start heading towards the sun?
Yeah, it can be possibly that two objects might be knocked way out there, and then one gets knocked into a different trajectory and comes in towards the sun. Another reason is the gravity of Jupiter and Saturn, especially Jupiter, the biggest planet in our solar system, can have a gravitational pull on them and alter their path, and that will cause them to come in. So yeah, there's a number of factors, and astronomers are still determining, why.
And what's the chances of one of them whapping into Earth, like in one of those movies I saw?
Yeah, well, people think that 65 million years ago, 66 apparently, 66 million years ago, there was a comet or an asteroid the size of Mount Everest, basically 10 kilometers in diameter, that came in and went smack into the Yucatan Peninsula in Mexico, and that wiped out the dinosaurs and so on. So there are chances of comets and asteroids hitting Earth, and we do have instances where it has happened, like in Chelyabinsk, and I probably said that wrong, sorry, in Russia, where that body came in, exploded in the upper atmosphere, and sent out the shock waves and broke windows and everything. And in fact, in 1908 in Siberia, astronomers believe that a comet came in and basically exploded above the trees and flattened all the trees, millions of trees.
I've seen that. I think I've seen a video or something of that. Is that right?
Yes, yeah. So these days, astronomers they've got search programs around the world where they're searching with big telescopes, searching for comets and asteroids, and basically trying to find any that might hit Earth. In fact, the work I do here at Possum Observatory when I'm not school teaching and surfing is following up newly discovered comets and asteroids and helping determine a path, and then based on that path we can see where it will go, if it's going to hit Earth or whatever.
And yeah, that is something to be concerned about, I guess.
Yeah, well, NASA is concerned enough to be searching for them and to be thinking about trying to devise methods of actually deviating them from their path so they don't hit Earth. I mean, they're talking about explosions near them to bear them away from Earth, maybe putting thrusters, rockets on them to fire so that it'll send it away from Earth, or veer the angle away so it doesn't hit Earth. Other theories are blow up, but of course, if you do that, you've got a whole heap of smaller bodies coming towards Earth. So, yeah. So,
well, let's hope Bruce Willis is around if one does come.
yeah, that's right.
He did a pretty good job. Him and Ben.
He did. Yeah.
Yeah. And how many are out there? There are a lot. I read somewhere like thousands.
Yeah, thousands. And astronomers think that there's probably trillions out in the Kuiper belt and further out in the Oort cloud. It's just they haven't been knocked off in their orbit or gravitationally pulled or disrupted by passing stars or whatever to bring them in. So a lot of them are sitting out there.
And you are actively looking for them from the Possum Observatory? Do you?
Yes, I do. I must admit, it's very hard now to discover, for an amateur astronomer to discover a comet or an asteroid. There's just massively big, expensive programs set up by universities and organizations to search for them. So they're seeing things that are just so faint that it'll be months before they'll be bright enough for me to see them, so, or other amateurs. So it's a bit of a challenge now.
So the chance of seeing the or hearing about the Possum Drummond comet is unlikely. Am I right about
Comet
that?
Drummond, yeah. No, yeah.
Why are there so many with two names? Hale Bopp. What, you know what?
Oh, so basically, naming convention states that, say you discovered a comet, then I discovered a comet, and then Mr. Smith discovered a comet within a couple of days of each other and reported them to the International Astronomical Union, the police of astronomy, basically. Then the first three surnames would actually be listed with that comet. For example, our comet would be Davies, Drummond, Smith.
I like the sound. I like that. Yeah. I noticed
too.
I noticed that there are two called Tuttle, aren't there?
Yes, yeah. So, there's been some very famous comet hunters over the years, and like Bill Bradfield in Australia discovered, probably about 17 or 18 comets, one of the most by an amateur astronomer in the world. In fact, he was born in New Zealand, believe it or not, and then went over to Australia later on.
What's his name again? What's his name?
Bill Bradfield.
Bill Bradfield.
Yeah, he passed away a few years ago, but yeah, and then you've got another person who passed away just last week was Caroline Schumacher, who was married to Eugene Schumacher, and some people might know the name Schumacher-Levy from the comet that actually split up into 21 pieces and smashed into Jupiter in 1994.
Wow. So one of the questions I've always had is, when I was a kid, everybody called it Halleys Comet, but then I suddenly found people are calling it Halleys Comet. Have you got any? What's the story there?
Yeah, I've heard Halleys Comet too. Yeah.
But it's Edmund Halley, right? The astronomer royal.
Right. Yeah.
And who names the comets? It's the police again, the IAU. That's
right. Yeah. There have been situations, especially in 100 years ago or so, before before telephones and telegraphs were a common thing, where, say, a local astronomer in say Napier might discover a comet, and then in the newspaper, the newspaper would call it Comet Bert, and then people would be calling it Comet Bert, but then later on, the official designation for the first person who discovered it would come out and find that, no, it's not Comet Bert, it's actually Comet Tuttle or whatever.
Tuttle again. These guys. Hey, tell me, there was that strange rock going through the sky, Oumuamua. That wasn't a comet, was it?
No, but basically that was an interstellar asteroid that came from another star. So the first time that an asteroid has been discovered coming from another star, and recently a man called Borisov, he discovered a comet that came from another star too. So it's pretty amazing to think that these objects have been traveling for must be millions and millions of years, and then they get pulled into the sun's gravity, and they pass basically through our solar system and carry on their merry way.
Now, look, while we've been talking, we've had a question come in from our good friend Richard Fish in West Auckland. And his question is, John, has any Earth spacecraft ever landed on a comet?
Yes, there has been.
Thank you, Richard.
Yeah, thank you, Richard. Yep. There was a comet that was landed on. It was 67P, and it's got a horrible a hyphenated name, which is really hard to say, but it's known as 67P, and the lander actually landed on it. The name
is so bad. 67P is a better name. It must be a terrible name.
That's right. 67P actually means it's the 67th periodic comet that's been discovered. So P meaning periodic. So basically it comes back around to the sun within 200 years. So because this comet here is on a regular path, NASA was able to plan the mission, send the probe to the comet, and they landed on the comet. And it's quite amazing. They had harpoons that would shoot into the soil or the regolith of the comet and anchor it there, because it's such a small body, it's got such a small gravity that it could easily just bounce off and go away. Yeah. They shot the harpoons into the ground, but it was so shingly, like we were saying, it's a conglomeration of loose shingle and rock and gas, and that the harpoon couldn't hold, and it actually bounced off there and then landed somewhere else. So NASA was able to say they managed to land twice on a comet. So
and what did they find out about it? That's an amazing story. What did they find out about it?
Oh, they saw jets coming away from it, cryovolcanism, basically, down subterranean. As it gets closer to the sun, things are getting heated up, and the gases expand and send out jets, which give us a coma and tails and things.
How long ago was this?
Oh, you've got me there, Gareth. But it was probably around about 15 or 10 years ago, I would say.
And what happened to has the comet taken off back to the Oort cloud with the NASA space probe on it?
Yeah, so it's a periodic comet, so it won't go all the way out to the Oort cloud. It'll reach a certain distance from the sun, and then it will come back. But yeah, I presume the lander is still on there. Wow. I think it was called Philae.
Wow.
Maybe from the Greek word philios, meaning love.
Oh, wow. Well, fantastic. So what's the next one we can expect to see?
That's $1 million question. The astronomers are always, and the public are always hoping that a new comet gets discovered and becomes a really nice, bright one. Most of the comets are fairly run-of-the-mill comets. We might get one or two. I think next year in 2022 there might be one that is naked eye. But it basically watch the space, watch these podcasts, and we'll tell you down the track when the next one will be coming.
Well, look, before we wrap up, I just wanted to talk to you about two things, and one is, what about this news at Rocket Lab? Have you been following that?
That has been listed on the NASDAQ.
I know. I got the $5.2 billion US dollars. That's what it's been valued at, based upon the closing price.
Have the vision and get the right people behind you, and away you go.
Well, that's right. I think you got the University of Southern California and NASA and a few other hitters. So that always helps. Yeah. We'll have to get on the phone to them when we finish and see whether they prepare to support us. I could do it. I could do with some of that 5.2 billion. Hey, and the other thing is that 15 years ago, poor old Pluto was downgraded. And perhaps you could tell our viewers and listeners why that came about.
Yeah, so with improved technology, larger telescopes and more sensitive cameras in the late 1990s, they were discovering more and more objects, kind of like Pluto, even larger than Pluto, out beyond Neptune, and discovering quite a few of them. And basically thought, well, if we keep improving our technology and discovering more of these bodies out there, we're going to have 50, 100 planets in our solar system. So the IAU, the police of astronomy, basically had a meeting in 2006 and sat down and had a vote. And basically they said that for a planet to be a planet, it has to obey three laws. One, it has to basically has to orbit the sun. So the moon, of course, orbits the Earth once a month. And so it can't be called a planet because it's orbiting the Earth. So a planet has to orbit the sun. It has to have enough mass to undergo different planetary differentiation, basically turns itself into a sphere with the gravity. And a third one that Pluto can't do is it needs to clear the orbit around it of other bodies. And Pluto basically doesn't have the mass, the gravitational pull to clear the area around it of all the other bodies that are actually orbiting near it. So for that reason, in 2006, the IAU voted that Pluto was demoted from planet status down to dwarf planet status.
Seems to be justified.
Yeah. I mean, I think some of us, the romantics, would like to see Pluto still as a planet, but everything else, smaller, whatever, be a dwarf planet. But you can see the scientific principle that they were trying to adhere to.
Okay, well, there you go. That's been very interesting, John. I've learned a lot, and I hope the people listening in and watching have learned a lot. So that's it from us. You'll be doing some surfing, hopefully, and the level 3. Can you do that under level 3 lockdown, surf?
Ooh, that's a good question, Gareth. I can't remember last time.
Maybe you can surf in a bubble. Who knows?
Yeah, that's right. Like one of those big plastic balls, just sliding down the wave.
Yeah, exactly, like they have at Eden Park at halftime.
Yeah.
Well,
good idea, Gareth.
There you go. Let's patent it. $5.2 billion. Here we come. Okay, John, I'm going to play us out now with our favorite song.
Okay,
Here
Gareth.
we go. Take me to Callisto so I can see the stars. I want to view the Milky Way from a terraform base on Mars. From a terraform base on Mars. From a terraform base on Mars.